Hi friends, welcome back to another episode of Making Things Fun, Cool, and Sexy. I'm your host, Christine Holly-No, and today's episode takes us into the world of precision, lasers, and innovation. Recently honored as Manufacturer of the Year by AM Bay Area, Turner Laser Systems is making huge strides in the advanced manufacturing space. I had the chance to sit down with their founder and CEO, Dr. Mark Turner, who brings an incredible blend of academic research and entrepreneurial spirit to the industry. Mark and I dove into how lasers are transforming manufacturing processes, how automation plays a critical role in staying competitive, and why precision is the future. His journey from PhD research to building a thriving manufacturing business is so inspiring. Let's jump right into my conversation with Mark Turner from Turner Laser Systems. Welcome back to another episode of Making Things Fun, Cool, and Sexy, where we explore the people and innovations driving the future of manufacturing. I'm your host, Christine Holly-No. Today, I'm joined by Dr. Mark Turner, CEO of Turner Laser Systems, a company pushing the boundaries of laser processing technology for advanced manufacturing. With a PhD in ultra-fast lasers for micromachining, Mark is an expert in precision engineering and has spent over a decade developing cutting-edge laser solutions for industries ranging from aerospace to medical devices. Since founding Turner Laser Systems in 2018, he has built a company known for its high-performance laser automation, bridging the gap between academic research and real-world industrial applications. As an innovator, Mark has multiple patents and research publications, and his work is shaping the future of laser manufacturing in the U.S. Turner Laser Systems is also a recipient of AM Bay Area's 2025 Manufacturer of the Year Award. Today, we'll discuss how lasers are revolutionizing precision machining, the role of automation in modern manufacturing, and what's next in laser technology. Mark, thanks so much for being here today.
Christine, thanks for being here, and I'm really excited to talk to you more about lasers, manufacturing, and appreciate you coming to see our facility.
And a huge congratulations again for winning AM Bay Area's Manufacturer of the Year for 2025. That's a huge accomplishment.
Yeah, it's a real honor to be recognized in the manufacturing space, particularly as a small business doing something new here with lasers. So yeah, excited to be part of the AM Bay Area and part of Bay Area's growth in manufacturing.
Yeah, we're so excited to have you a part. And can you explain, how did you go from a PhD into entrepreneurship?
I think it's something that often people see. I kind of stopped, say, my full-time job and jumped into starting a business. But there was sort of a lot of prep work that went into it, even going as far back as my bachelor's. So I did a bachelor's in experimental physics, and even then I was thinking about what do I want to do with my career? I love working with physics and mathematics and science. I chose a field in lasers specifically because I wanted to be on the cutting edge of innovation, be creative. It sounded like a fun way to sort of live my career. So ever since I've doing my bachelor's, I've always thought about getting into entrepreneurship. I didn't really know exactly how or what I wanted to get into, but since then I've always been sort of aligning the things I've been doing within my career towards that pathway, and a big part of that was doing my PhD. I did a graduate certificate in entrepreneurship back then during my PhD. That was when I lived in Australia, and then during my studies came to the Bay Area, fell in love just with the culture of innovation here, the fact that we have an epicenter for lasers, we have an epicenter for manufacturing, and I sort of knew this was the space that I wanted to work and surround myself with, and part of my vision to getting into entrepreneurship. So it's been 15 years that I've had the dream of sort of moving into this world.
That's incredible, and you're so right. We're so lucky to live in the epicenter of, lasers, innovation, tech, AI, and now manufacturing. What was the gap that you saw in lasers where you saw this huge opportunity that you wanted to start a business in?
Good question. So I'd worked at a couple of laser companies. A lot of my role was an applications engineer. So the type of work that I would do would be, we have the lasers. Often people in the laser industry call it the solution looking for a problem. A lot of times what that means is we're looking for applications where does it make sense for us to use these lasers for manufacturing? And so I would play that role where I would work out, is it feasible? Can we do it with a laser? And a lot of the time I noticed that we didn't quite take it, at least on the laser side of the sort of ecosystem, we didn't really take it all the way to manufacturing success. And I noticed that there was a large gap between the feasibility work that a lot of, say if you're manufacturing a product and you say, I want to cut this material as part of our product manufacturing process, you'd go to a laser company, they test out and they go, yeah, it's feasible, we can cut it. Like, look, it's a really nice, beautiful quality cut. There's a big gap between there and we're running high volume manufacturing. We have high quality, high yield, high throughput, and we're just, have good operational efficiency. And so I really wanted to address that gap because I didn't think it was being well managed and run just on a industry level. So I built the company really focusing on that transition phase of going from feasibility to manufacturing success. And a lot of that comes to understanding for each program, like, what are you manufacturing? Tell me about your upstream, your downstream processes. How does this process we need to do fit into the big picture? What is your big picture in manufacturing? And then designing the solution to fit those needs. And part of that education process is understanding what are all the things that could go wrong. Because it's not as simple as you just take a laser, throw it into a robot machine, and out come good parts. So a big part of what we do as a company is we call it bridging the gap or bridging the valley of death. And it's understanding like what are the risks that we need to mitigate, and then how do we approach it through good scientific methodology.
That's awesome. And you gave us a quick tour earlier, and I thought it was so incredible. I didn't understand what micro machining was until you described it to me. So we do machining with our CNCs, and they're like giant drills and end mills and all these big tools that will cut into metal or plastic. You are cutting like tiny, tiny little lasers into different materials. Can you share what micro machining is?
Yeah, it's sort of an umbrella term that we use for a variety of processes. It could be anything from cutting materials, dicing wafers or larger sheets into smaller pieces, etching features, three-dimensional features. We can etch curves, which means we can etch contours into materials as well, like chamfers, bevels, drilling tiny little holes. We can take really thin layers of materials, which are tens of microns thick, and bond them together. We can take materials that don't want to bond them together and bond them together with lasers as well, like dissimilar metal welding or dissimilar material welding. So there's a whole variety of different processes that we work with generally. And I'd say the most common materials we work with are semiconductors, polymers, metals, glasses, crystals, those types of materials. So it's a pretty broad application space.
And which industries are you supporting? I know medical devices, aerospace. You just stated semiconductors. What else?
I'd say we're pretty broad. It's one of the reasons why I love working with lasers, because literally every week we get a new product in that's something we've never seen before. So just to name some of the industries we've worked with in the last few months: battery, solar, fusion. Other forms of renewables, semiconductor in many different form factors, medical devices, particularly implants and sensors, sometimes the other forms of medical space as well. We're doing a lot of work with aerospace, particularly in the electronic side of aerospace right now, and space industry, and a few others, consumer electronics and display, augmented reality, virtual reality. So a lot of the emerging technology, particularly based here in the Bay Area, it's what are people manufacturing today or trying to manufacture today, because a lot of the times we're not so much in the late stage of the manufacturing cycle. We're often involved in the early stage where it's innovation, creativity, building pilot lines and ramping up pilot lines. So we're often involved when technology is sort of at the cutting edge, and we're working with a lot of the trends. So
that's awesome. I mean, again, very lucky that we get to live in Silicon Valley. Us too, right? Every day we get so excited to see, oh, who can we help today? What industry, what customer is going to call us to get something manufactured. So it's pretty awesome that, there's so many different industries that need manufacturing, and lucky for them, they have someone like you. And you showed me your laser lab earlier too, and the R&D work that you do is so incredible. You don't guess, right? If a customer comes to you with something very difficult and challenging, you will do the R&D work to make sure that it is viable before you even create a tool for them. Share a little bit more about that process.
Yeah, that's a good point. So we do something called like qualifying processes for manufacturing, and it's something where we, as I kind of mentioned, we're sort of bridging that valley. So what we like to do is look at all the risks of a program, and sometimes they're not even technical risks. They might be commercial risks related to schedule, or can we just manufacture to volume at the sort of price point that we need to hit? If we're trying to manufacture a product to a certain cost point, it's like, can we help them manufacture at scale to that cost point? So we have to think about how do we scale up the processes to achieve those sorts of volumes and throughputs. So that's a lot of what we build in our program methodology. We call it 360 mastery methodology. The idea there is, so a lot of our team, we're technical people, so we focus a lot on the technology, meaning the physics and the engineering that we do. But a big part of creating success for us is to take off the technical hat sometimes and really just think about manufacturing and business. How do we make it commercially successful? And the ultimate solution is where you sort of have a balance of the viewpoints and perspectives that you look at it. So we build that into our infrastructure for how we work as an organization. We also build that into the way we structure our programs. And a lot of that actually aligns with our partner Owens Design, who we're based inside their building here today. They've built that out in the semiconductor and advanced manufacturing industry for 40 years, where they take complex processes and how they integrate it into the tools, and they have a similar workflow as well. So another one of the reasons why our companies work together and work well together.
Yeah, it's so awesome. Like, you come up with the idea and you get it manufactured right here, and you're working with your manufacturer in the same space, and you get to be very hands-on. How, let's say if I come to you and I'm like, okay, I need this type of laser for my manufacturing. How long does it take to get from concept to an actual tool?
Ooh, great question. Could be months, it could be years. And it really depends on the stage at which that, say, program is at with its manufacturing line. A lot of the times we'll work with product development teams who aren't quite ready to launch a pilot line, but they're trying to get ready. And so we work with a lot of those teams where we might spend 3 months to 6 months working in our lab, where we're just trying to work out, can we do it? And then what's the best way to do it, thinking 5 years ahead. So those types of engagements, we're just working many months in our lab. Then there's some teams we'll work with where they've got to go into production like now or yesterday in many cases. And in that case, it's more of a rush to go through the same steps and the same processes, qualifying the processes in the lab. And there we'll try to condense that period down into maybe a month or two. And from there, either way, we then go into what we call like the tool build phase, where we're building the manufacturing equipment, and that can take anywhere from a few months to about a year if it's a really complex project with a lot of components and robotics and automation.
That's so incredible. So I guess it just depends on the complexity of what the customer needs. And I can't wait to take another tour of your lab, like where we'll get to see all of your machinery. I know it's pretty fun and exciting in manufacturing, but we also face quite a bit of challenges. What would you say are some challenges that you're facing or advanced manufacturing is facing right now?
Good question. I mean, as a small business, it's always challenging working in capital equipment. Generally, capital equipment industry are larger automation companies that work in this space, a lot of the times because it ebbs and flows just naturally as a business, rather than having many smaller orders. If we were, say, a contract manufacturer, we have larger projects that we need to work on. So that's always been a challenge of building the company and trying to work out how to balance investing in growth of our lab, our team, our infrastructure, and then the number of projects that we're running. That's a challenge too. It's also challenging to work out visibility for how our clients are going to ramp in their production schedule as well, because they may have a vision and a plan, but a lot of the times plans change. And what might be a 3-month program to ramp now becomes a 6-year program to ramp or an 8-year program to ramp. And so that can be a challenge as a business, because we need to be able to work with our clients and create the infrastructure to support their ramp growth as well. So these are just a couple of things that's always on the back of my mind, of making sure we're carefully growing and expanding our business at the same pace that our clients are growing as well.
Yeah, that is very important, and setting those expectations for the customers as well, of, and this is what I work with a lot too, is how do I express or update the customer for delays without really upsetting them. Like that is, for me, the biggest challenge I feel like I face at work is when I have to disappoint the customer and say that, you needed this in 2 weeks. I'm so sorry, it's going to take 4 weeks. And for me, it's way different. I'm not creating some complex machinery. It's just components, but still, that's a huge challenge that we face. And speaking of growth, where do you foresee Turner headed the next few years?
Yeah, so I feel we're relatively building our reputation now. If you need something high precision, you're working with ultra fast lasers particularly, we're quickly building a name and a reputation to be sort of the go-to machine builder for that sort of space. I see us sort of solidifying our presence in that market. We've also got some key partnerships that are helping us bring in more technologies into our company as well. Different types of lasers, more powerful lasers, and also the technologies sort of enable the powerful lasers to really utilize their true value or their core value. So I see us sort of advancing some of our technology portfolio, let's say, to enable those markets. I see us also sort of expanding more from just being a West Coast integrator to, supporting tools that are deployed all across the United States. And we're actually already starting to see that in the last 2 years. We've had just as many tools being deployed in West Coast as we have out in the Midwest and East Coast as well. So we're starting to expand our presence just generally in the United States.
Oh, that's awesome. Are you going to be moving your facility or expanding perhaps another facility in the Midwest or another state?
For now, in our foreseeable vision, we plan to stay here. We've got really great relationship and partnership here with Owens Design. This is just a great place to have our headquarters and our core manufacturing, just because a lot of our partners are literally walking distance or a short drive from here. And it's so valuable when you're building something for the first time, noting that a lot of times when we're creating these tools, it's the first time we might be combining this particular laser with this particular optics in this particular configuration. So it's a prototype, and being close to your clients is important, but also being close to all the partners that we work with is really important. So being able to pick up the phone and say, hey, we're at this stage of the build, we need your help, come on site and help us through it, is so critical. When you talk about protecting schedules and lead times, that's probably one of the most important things that we can do, is be close to the partners that we work really closely with in the programs. Having said that, I do see us sort of building some sort of presence out in the East Coast. We already talked about building sort of an applications lab and service center to enable us to support those clients out in the East Coast.
That's great. And you just made me very happy, because I selfishly wanted you to say no, because I want California, and in particular the Bay Area and Silicon Valley, to have a thriving manufacturing community. So we would love to keep you here, and if you grow, please continue to grow here in Silicon Valley. So as an entrepreneur, I know that we face a lot of challenges, and it actually shapes how mentally strong we could become. What was one of the most difficult challenges that you have faced as an entrepreneur, and how did you overcome it?
I remember there was a meeting once where we'd worked with a client where we'd already sold them a couple of tools, worked really hard to take good care of them. It was quite a large program that was going to ramp up. And they were sort of at the ramp-up phase, and they'd placed an order for well over $1 million worth of equipment. And this is kind of in the early stages of our company too. And I remember sitting in a meeting, and they told us the news that they'd sort of made a major pivot in their program schedule, and they canceled the orders on us very, very early. We just gotten started on building it too, and sort of like planning that had gone. We'd spent maybe 9 months going into sort of planning these reorders and re-engineering them. So that was a hard sort of like a punch in the gut sort of feeling. And it was a time also that I realized it's like moments like this that your team's going to look to you to how we lead and navigate it. So I remember in the meeting just having to take a deep breath and go, all right, yeah, this is frustrating, this is disappointing. I'm probably worried, right? Because I've been sort of planning things out for our year based on this one large order as being was a big part of our sales for that year. And just thinking like, all right, how do you want to show up? How do you want to show up right now to this person that's giving you news? Like, and at that moment I was like, well, I'm going to listen to them. I'm going to listen to what they have to say. I'm going to try to be compassionate and understanding to them. I'm also going to be honest with them and just say, like, this is really disappointing too. And it was, I think in that moment I was realizing, yeah, like it's moments like that in part of being an entrepreneur and leading a company is to try to role model your values and to just build that into how you run every day. And I also learned too in that exercise, I don't want to just be role model in those occasions, but I also want to let the team know, like, that was challenging. That was actually a really hard moment. Here's how I navigated it, because I want to also teach within my team of leaders as well, like how they can sort of apply those values and systems to the company. So I remember looking back and I go, like, I really appreciate the way that unfolded, and the way sort of operating, say, by our values just really is, I think, like a key tool to use as an entrepreneur, as business owner, and like how do you navigate challenges in the business.
I love that you're authentic, transparent with the team, and really helps them and teach them how to deal with difficult situations, right? Like, life isn't perfect, and how do we navigate through these challenges? And you set the example for them. So that's pretty awesome as a leader, what you did.
Yeah, the way I also look at it too is, like, people are going to know, they're going to sense things too. So it's better to be authentic and just to share what's presently happening, and then get everyone on board on the same side. It's like, all right, so what do we got to do, and pivot as a company? And we're actually able to take that opportunity, pivot, and then create growth, and still be profitable throughout that year and continue growing. So it was just a hurdle we had to overcome as a team.
Yeah. Incredible. I love that story. And thank you so much for today. This has been a wonderful podcast. Let's wrap up, and I want to hear what new or exciting innovations or projects you have coming up.
So I can't tell you specific applications that we're working on. Obviously, they're confidential, but the types of technologies that we're working on that I'm really excited about are medical devices and medical implants. I think a lot of the technologies that we're working on, you probably would have seen, like, tiny little things that we manufacture in the lab. So a lot of that's to support things that are going inside, let's say, the human body. And we're sort of a lot of times familiar with catheters and stents and things like that. What I think is really interesting are medical implants that are measuring or, say, actively working inside of the body as well. And to me, I start to look at some of these technologies that we're supporting and go, it kind of reminds me of, like, cybernetics in sort of futuristic sci-fi movies. And I know in sci-fi movies we always have this dystopian view of what the future could look like, but actually look at what these technologies are doing, and it's really, a lot of it's like quality of life and just helping enable better life, and not just about longevity, but being able to enable us to, like, live our lives, particularly if you've got a disability, a disease, or something that you're working with, or even just diabetes, which is a really big problem that we have here in the United States as well. And a lot of technology is going to, like, how do we work with this? Obviously, it needs to go hand in hand with just better health as well. So that's medical device has always been an area that I'm excited with. And I think the other area is energy. We're seeing solar is starting to come back here in the United States as well. We've seen battery, particularly here in the Bay Area, just have this massive surge in manufacturing innovation in the past 5-10 years, which has been great. And then we're also starting to see applications in, let's say, more futuristic technologies like fusion technology, for example. And I think as a physicist, I'm pretty passionate about sort of energy in general.
Oh, that's so awesome. And you're right about biotech and longevity. They say that probably in our lifetime, the average age will start being 120 years old. We're going to live until 120. What are your thoughts on that?
Well, there's a couple of things. I could see us growing older. I think we also probably need to learn to just how to, like, more relate. How do we relate to each other? As we start getting older, we're going to be living longer with each other too. So we're going to be working longer with each other. The average working age is going to be longer as well. So I'm open and curious to see what sort of unfolds there.
Awesome. Well, thank you so much for your time today. I'm so looking forward to seeing you grow further and further. And thank you for all you do in manufacturing in Silicon Valley.
Thanks, Christine.
Yes, thank you. So we're here on the production floor of Turner Laser Systems. Tell us about these 3 awesome machines that we have right behind us.
Yeah, well, first of all, they're called the Kanga, Wallaby and Wombat. So I've named them after Australian marsupials. I'm born and bred in Australia. The Kanga is our most popular product that we make. It's designed for both R&D, product development, process development, as well as high volume production. So you can load in a wafer, a material, a sheet, some sort of part that you're going to manufacture, push one button, and then it will run a fully automated process recipe. It will do everything from aligning very precisely onto a part, maybe measuring it in 3 dimensions, finding, locating the part, and then doing some laser process. And it could be wafer dicing, drilling, welding, ablating, etching, a whole variety of different processes. In fact, some of these machines do multiple tools, almost like if you imagine a machining tool where you have multiple different types of bits or heads in there.
Yeah.
We can actually build them into these machines so they can run multiple functions. So this is our Kangaroo, is our most common tool used for these types of processes.
Oh, awesome. And how many lasers do you have in this one?
This is interesting too. It's got one laser, but it has 3 beams that comes out of it. So you've got an infrared beam, a green beam, and a UV beam. And you might want to use these different beams, the different colors of the laser, to process different materials. So a lot of the times polymer materials work better with ultraviolet beams, and then infrared is commonly used for a whole variety of materials. In fact, there's an ultra fast laser inside of here, so you can do a lot with each of the 3 different wavelengths.
Oh, that's so awesome. All right, what's this one called again?
So this is the Wallaby.
Wallaby,
so
got it.
Kangaroo being the larger marsupial, the Wallaby is kind of the cousin, smaller marsupial. This product here, we designed this to be extremely versatile. We can configure this to do a lot of different things. The Wallaby, on the other hand, we designed this to be a little bit less configurable. We wanted to make something that was smaller, more compact. It comes at a much lower price point compared to the Kangaroo does, but it still has a very similar precision level, just a smaller area that we can manufacture. So instead of manufacturing, say, 300 millimeter wafers on here, we could do sort of 200 millimeter wafers, or it doesn't have to be a wafer, it could be a sheet, a part, or a tray of parts, for example. Similar levels, sort of vision and controls and software, just a less subset of devices and variations inside of there. With all of these 3 tools, though, we can customize what laser we put inside. So what we do a lot of times is we have the lab in our other building where we try to work out what's the best laser for your specific process and your application. So we spend months working that out. And then once we understand, this is a UV laser or an infrared laser or whichever laser type, then we put that laser into one of these 3 tools. So here we just got a much smaller, compact footprint. Again, great for R&D, pilot lines, process development. Once you get to a point where you're running in higher volumes productions, you need automation, robotics, and you sort of migrate up to the larger size Kangaroo platform.
Oh, awesome. And this one is another R&D one.
This is definitely more designed for R&D teams where they may have a program that's running for 6 months to 12 months, and they need to show that this works. And they're doing a lot of exploration. A lot of times they're working with material science and just trying to understand the materials. Don't really need automation at that point. I just need something quick, fast, and to show feasibility. So we designed the Wombat to be something that you can get. It's literally a benchtop system as well. So you can, if you've got a lab, you can just put this onto a bench. All you have to do is plug in electricity, air into the machine, and it's ready to go. So you would just open a drawer, drop in a sample, and it can process parts. And this machine here, you would insert fixturing to align the components into it.
And each one of these are customized to and tailored to your customer's needs.
Yep.
Depending on what laser they need, how big the bed is, all of that.
Exactly.
Oh, so awesome. And these are the 3 different sizes. Do you have any other sizes, or are these?
These are our 3 what we call platforms.
Okay.
So if it's possible to make a solution work with a platform, this is your fastest, quickest, and sort of cheapest method, at least for us, to build a manufacturing tool. However, sometimes it doesn't fit in one of these platforms, or it's a weird form factor, or maybe there's a whole bunch of other automation that needs to be done, and then we need to design the laser to sort of fit into the automation. So we do fully custom machines, and that's where we partner with Owens Design that would take on that larger automation project. And then we build, essentially, we take the guts of the machine, which is kind of like the laser and the beam delivery. We take that and then we build that as a subassembly into a much larger, fully custom automation tool.
That's awesome. All manufactured and designed in California.
Yep, right here in this building. Yep.
Awesome, awesome. Well, thanks again for this amazing tour and your time today.
Yeah, thanks, Christine.
Yes, thank you. Big thank you again to Mark and the Turner Laser Systems team, and congrats on being named Manufacturer of the Year by AM Bay Area. I hope this episode opened your eyes to the exciting ways lasers and automation are elevating American manufacturing. Well, that's a wrap on today's episode. If you or someone you know who'd like to be on the show, we would love to have them on. Just drop me an email or shoot me a DM on Instagram or LinkedIn. Details are in the description below. And if you had a blast listening, remember to hit that subscribe button, share the episode, and help spread the love for manufacturing. Until next time, keep on creating, keep on innovating, and always remember to keep it fun, cool, and sexy.